This episode of the Power Podcast is sponsored by Siemens. From decentralized industrial applications to heavy-duty power plants, Siemens is with you from the start with the most complex portfolio to cover your needs. From instrumentation and controls components to powertrains and full turnkey solutions, Siemens provides ingenuity for life.
The Power Podcast is the latest offering from the longest-running power industry publication in the world. Established in 1882, the Power brand is dedicated to providing its global audience with news and information important to the power generation industry. Now here's the host of the Power Podcast, Executive Editor Aaron Larson.
On this episode of the Power Podcast, I'm joined by Reed Lengel. He's the product line manager for the SGT 800 solutions, Siemens, I guess, medium-range gas turbine. Is that what you would call it? Or
Yeah, I'd say that's fair. Medium gas turbines, or we'll call it the industrial side of our portfolio as well. The industrial-sized gas turbines tend to be on the smaller size.
So in a range scale, it's basically from, a 37.5 megawatt, I think, at the low end, to...
So overall, we really have we go down to 3-4 megawatts if you're really looking at the full spectrum of our portfolio. But I tend to focus more on where the SGT 800 will go from about 48 megawatts to 57 megawatts is where our latest version currently is in a megawatt output.
Okay, and that would be in a simple cycle. Combined cycle obviously would be higher? Or?
Exactly.
Okay.
So if you go combined cycle, there's actually can be several different configurations, not whether 1-on-1, 2-on-1, and we actually have a 6-on-1 that's actually under construction right now.
Really?
Yeah, so that's a project down in Panama. So
what are they going to be using that? Is it for electrical generation specifically?
That's specifically electrical generation, okay. Yes. But with Panama, it's interesting because obviously not as big of a grid as you would see, let's say, in the U.S., and so grid stability is very important, but they don't have such a large grid, so having the ability to run at variable loads, depending on the need, and they intend to grow their infrastructure, so having that ability to then add higher power output if need be by just shutting down certain gas turbines, but they still have that base load efficiency level. Okay. So that's key, because these are our newest versions that really have had a lot of high increases in efficiency recently, real technological advances, and so whether it's 6-on-1, 5-on-1, 4-on-1, you're essentially still reaching near these base load efficiency levels, even at all these part load percentage points.
Do people find it more beneficial to have a 6-on-1, for instance, rather than a large HL class with 1-on-1 type situation? It's just more flexible in that way?
Yeah, it depends on the application. I mean, there's definitely the need to have these the 1-on-1, say the HLs that are, going to have primarily baseload power and just a larger power block, higher power density. So there's definitely a need for that. But I think there is an added level of redundancy and reliability that some plants do want when you're talking about these, multi 5-on-1, 6-on-1 type of plants that, you just don't quite have when you're talking about the larger scale.
And I guess you can do maintenance on one unit without taking the whole plant down. When you have a 1-on-1, you're basically out of service when you're doing maintenance, whereas these you can do one at a time.
Yeah, exactly. So you'll constantly have, you really can have at least 5 of your units, up at any time, even during major outages. It's easy to space out, and so definitely helps in your overall availability that you're able to provide power.
Okay. Let's talk about some of the applications
sure.
that you're seeing it used, because it is important for combined heat and power
right.
Solutions. So can you give some specific examples on that?
Yeah, absolutely. So combined heat and power with this smaller range, it is seen a lot with combined heat and power and industrial applications. One specific example, we actually have one that was built in the U.S., even though overall I'd say it's not as common, combined heat and power in general, as say in Europe. Right. Pretty much 100% of the plants that are on this scale at least are all combined heat and power. A lot of district heating needs and steam production. But we have a City of Holland in Michigan is actually a 2-on-1 plant.
I wrote about that.
Did you?
It was a power top plant last year.
Yeah.
I found it fascinating, 2 SGT 800s and then a SST.
SST 600 or 400, I believe.
400.
Yeah, SST 400 steam turbine. And yeah, the way that they were able to, the city worked together with them on that plant and had the snowmelt system helping the streets and prevent salting, and even just the plant itself, I thought was pretty incredible.
It's a beautiful plant.
Exactly.
They really designed it with a structural, symbol that really stands out in the community, and I think it's really quite a phenomenal. And they have a area where they can go and give tours and teach people about generation and electricity.
Yeah, I thought that was something you don't see at many power plants. It doesn't look like a power plant by any means. The long glass walls on the side and the long hallway, you can go and you can actually see into the plant and learn about the process. So it's places, honestly, people bring their families to go see as like a park or an amusement, to come enjoy their afternoon.
And they have, I think it's over 5 miles of walkable distance downtown now, where they basically the snowmelt system keeps that dry during the wintertime, and it's just been a real boom for the city and for their economy. And,
Exactly.
It really has been, and it's well supported by the community. I mean, they were really behind this project because of all of the benefits that they receive from that plant.
Oh, for sure. Yeah, it's really an impressive plant overall.
Other examples, like maybe over in Europe, what are they using these
for? So we have one that I thought was really interesting because it's on an island in Malta. So they have, this one's a 3-on-1 configuration with the SGT 800. And they were able to actually integrate this with an LNG regasification facility. And so they're burning the regasified LNG as it's right there on the coast, basically. And then on top of that, they have the waste chilling that they have from the LNG process, the regasification process, that can then be used for the air inlet system. So because, it's pretty hot in Malta. So you get those hot days and you're able to cool your inlet air with this waste chilling that would have just, gone in the atmosphere otherwise, and can gain, extensive amount of megawatts and serious gains in efficiency as well.
Right.
So that was an interesting solution that...
And actually, I was going to ask you about efficiency, because you said there have been marked efficiency improvements recently. What sort of things have led to that improvement?
Sure. I think that the market itself and the attention that's been brought to it has helped. You just talk about technology and funding that's going to go to where there's a market, right? And when there's the need. And I'd say from this power band, looking at the 800 class, it's 50 to 60 megawatt gas turbine class. In combined cycle, if you look back, say 2005, efficiency, like the market leading efficiency was probably about 55%, I believe. Then over a 10-year span, if you're looking at 2015, the efficiency had gone up 1%. So it went from 55 to 56.
Which doesn't sound like a lot.
It's not overly impressive, really. And I think a lot of that was the need wasn't there, or at least the demand in this class. A lot of attention was always on the larger, always get bigger, get more efficient.
Right.
60% plus, all of this on the large scale. But if you look now from 2015 to now, it went from 56 to nearly 59% now. So I think it's 58.6 right now is where the SGT 800 2-on-1 efficiency level is at, which is currently the market leader for this power band. So it's almost tripled what was done in a 10-year span if you're looking from 05 to 15.
Years, yeah.
Exactly. And I think a lot of that is really just a testament to the market itself and the demand and the funding and really the technology that's been seen in the gas turbine improvements.
And has a lot of that stemmed from the improvements that were made in the larger turbines, and now they're just bringing that technology down into maybe this smaller turbine?
Oh yeah, I'd say there's definitely a correlation there. I think that a lot of this, in terms of just manufacturing ability, coatings, cooling technologies, and I think a lot of that is definitely, you look at the manufacturers, only makes sense to utilize this, these advancements and developments across your portfolio. So I think that's definitely played a large part. I know that for the SGT 800, again in particular, they pretty recently have begun using additive manufacturing for their combustion system. And so all of their nozzles actually for all of their new units on the 800s are all done through 3D printing, this additive manufacturing facility in Sweden. Okay. So really been able to get precision level manufacturing that could have never dreamed of, prior to these new processes.
Right. And it's really interesting how that type of technology has improved the manufacturing process. So where is the SGT 800? Are they all manufactured in Sweden? Or?
They are.
Okay.
Yeah, we have a location in Finspång, Sweden, where they manufacture. They have 4 different gas turbines that they manufacture there, actually. It goes from the SGT 600, 700, 750, and 800, which spans about, let's say the 600, I believe, is down at around 23, 24 megawatts, up to then the 800 being their largest at 57 megawatts.
Where do you see the biggest demand for these turbines? Like, is it overseas or U.S. or just kind of general everywhere, wherever they need these?
I'd say there's increases in a lot of places. I'd say in the past, the majority of the units I'd say right now are actually being seen in Asia. So Asia, there was a big boom for the 800. We have, I think, 70 units actually in Thailand. So it's been, the unit's been around since 1999. So it's had some time, but these are relatively recent. They had a big boom really in Asia as well as Latin America. Have over 20 units in both Bolivia and Argentina, respectively. So there's definitely a lot of increases that have been seen there for the 800. But even in the U.S., we have between the city of Holland, I mentioned, went commercial just in 2017, and another project in Michigan that is being built as well. So I think it's becoming more and more. Historically, maybe not as much. We have about 14 units still in the U.S. But with the changes that are being seen, and I think the desire for more smaller units and distributed generation, more on-site, kind of getting closer to the source, I think that's only going to increase. Yeah,
and that's something that we've been following a lot because it seems the entire industry is becoming more distributed. You see a lot more wind and solar, and so these small turbines placed strategically in different areas where they can support the grid in different ways, I think is probably a great option.
Definitely. Yeah. Definitely is. Yeah, you see the fluctuations in the renewables, and you're in certain locations that talk about, the wind in Texas and solar in California, places where you're getting these significant swings, and you've got industrial processes or even data centers or places that have steady power needs or steady steam production needs that can't handle these fluctuations. They need to have direct power supplied or direct steam production. So they really taking it on themselves to, I think, we even heard the keynote. Oh, it was interesting with the MGM. The MGM director talking about them really going out and sourcing their own power and really looking in these solars and all these different renewable projects to help source their own power.
Right. The 800, is that well suited to ramping up and kind of being the backstop for solar and wind? Is that something that is really important to do?
Yeah, so it's a good. I'd say it's got a good diverse. A variety of applications, I guess, that it can cover, and it does have that ability. When you look at the gas turbine itself, it can get up to 57 megawatts full baseload within 10 minutes. And that's from cold stop. So if you're looking, it has the full, 58.6 combined cycle baseload efficiency. But if you need quick power, you can have over 50 megawatts still in 10 minutes. So depending on really what the application, what the true customer needs are, it can really cover both of those needs.
Let's talk back about your presentation. So what are you seeing in the power market? How is that changing?
Sure. So try to look and get a better understanding of really where the gas turbine sales have been recently. When you're looking at them as a whole, there's been a little bit of a decline over the recent years. It's been very noticeable on the market as a whole. But when you really dig into it, and I know looking on the smaller scale that I'm more interested in, at least with the SGT 800, that fleet, you can see there's actually been pretty significant improvements or growth in this part of in this power band within the portfolio, where there's been a really decline over the last 4 years in the total gas turbine sales. Now this is just globally looking at all gas turbines. In that same time frame, the market share of this 40 to 90 megawatt power band gas turbine has actually doubled. And so it's been looking at, again, like 40 megawatts and up, which, again, is a broad range, up to over 500 megawatt units in some, but the market share for this 40 to 90 megawatt band has actually gone from just under 20% to up to 40%. So I'd say it's very significant change and really shows the attention that's been brought and is really being looked at for these smaller type of power plants with similar capabilities, but just an added level of, again, maybe redundancy and reliability and more risk-adverse option as opposed to just putting it all into a large plant.
I'm guessing a lot of high energy users in the industrial sector are looking at these turbines. Is there specific industries that it really suits well? Is mining something that would look at this, or is there any others that you can think of?
Generally, for the combined heat and power aspect, I mean, for the U.S. in particular, there's really three main industries that have a main focus with combined heat and power. It would be bulk chemical, refining, and paper, I guess, are really the main ones that they have here, with I think steel refinery probably under there as well. And there actually is, look at some of the numbers even from the EIA's latest energy outlook that they put in just a couple months ago. The bulk chemical actually is looking to increase pretty significantly in their power needs, and more specifically on-site generation. So that's one specific area that really could see some growth in the U.S. in particular for on-site power generation, combined heat and power application.
All right, so where do you see the 800 going from here?
Sure. So as I mentioned, I mean the advancements have gone up more significantly as of late than in the past. It's been around since 1999, so it's every step is really very specific of evolutionary move, just really gaining on efficiency, on power, and really the same core engine that they've had since the beginning. But with this demand that's being seen and really the growth in this power band, I really only see it continuing to improve both in ability and really the efficiency. You look at the performance levels now, almost 59%. This is actually more than the large-scale gas turbines were back in 2008. The market leader was less than 59% in 2008 on the large scale, and that's about where we're at now. To think that we can't go to 60 or higher, I think that's the only way it's going to continue to go.
Yeah. And it seems like everybody's putting their research dollars into improvements in coatings and improvements in other areas on gas turbines.
Exactly. And like you mentioned before, when even on the large scale, whether developments on the small or large scale, a lot of these improvements in gas turbines and coatings, they directly translate. And I think it's definitely going to be used on that scale, especially when you see the need for it and really the opportunity on this, whether it's SGT 800 or just in the smaller band.
Now, this may be off topic. I don't know that this specific example was on an SGT 800, but
sure.
We're involved with the CTOTF, Combustion Turbine Operations Technical Forum.
Okay.
And there's an award that they were giving to a plant up in Oregon. I think it was the Klamath Energy plant.
Okay.
And I think it was a Siemens turbine, but I don't know if it was an 800.
Right.
And they were having a problem with humping or something where the turbine casing was cooling quicker on the underside than on the top side, and they added some forced air cooling into this system to keep it even when they came down offline, and it solved their problem. And so that they actually won an award for this new solution. They used a compressed air system, and then they integrated that into their overall compressed air system, and they say they're saving a lot of money on their balance of plant costs, and it solved their problem with this humping issue.
Okay.
Are there other types of, one-off improvements that you could see that might be incorporated into other plants?
I'd say as far as improvements such as that, I guess that's like almost kind of a very outside-the-box type of
a thing.
I mean, thinking of just even other things that may be seen, maybe the technology or changes that could be coming. I mean, maybe the fuel flexibility is something I think that at least is becoming more of a hotter topic, I'd say. Maybe a little bit different than that story, but
right.
Just thinking about even the hydrogen capability is something that really comes to mind. And even with the advancements with the SGT 800, you mentioned they currently had the ability to burn up to 50% hydrogen in these units, and even on our aeroderivatives can burn 100% hydrogen.
Really?
And I think that's even a lot of that is directed to the growth of renewables, I think, even because there's a lot of, if you're like the power to X topic and talking about, what a lot of this renewable power can be used for, and which is essentially just another way of storage, right? You talk about battery storage, thermal storage, and being able to produce hydrogen from this power being generated from wind turbines in the same way that you can then burn later on in gas turbines. I think it's just another advancement that really can take advantage of this changing market and this additions in renewables.
Yeah, that's a good point. Because I know electrolysis during times of high solar power, when it's not necessarily needed but it's available, you can use it to create hydrogen and store it in the pipeline or in tanks if necessary, and then use it in gas turbines when the power is needed and the sun's not shining.
Exactly.
So, yeah, it's great technology, and
definitely.
I'm sure it's going to continue to improve and become even more important.
Yeah, even on the 800 scale, I mentioned the air derivatives, already have the ability to burn 100% hydrogen, but there's, already a roadmap even for the smaller scale industrial size, the 800s and 700, 600, to all be really reaching these same levels. So I think the attention is definitely there.
And I don't know, maybe you don't know the answer to this, but what is the big difference between burning your regular natural gas to go into hydrogen? Is it a higher firing temperature that you have to deal with, or what is it?
Generally, it'll be a little bit lower firing temperature, I'd say, for the most part with hydrogen, and a lot of that is really due to emission control. So that's where you'll see a little bit of difference there. Yeah, other than that, I'm not involved directly with a lot of the technical detail there, or some of the the development design.
Some of the Siemens turbines I know are capable of firing on landfill gas and diesel and regular natural gas and propane and other things. Is that the case with the 800?
Yeah, so the 800 actually has a dry low emission dual fuel combustion system, and it's an annular combustor. So it's 30 burners all in just one giant annular combustion system, and it actually has the ability to burn natural gas or diesel fuel, and can actually burn diesel dry. So where the majority of gas turbines really will use water injection to control their emissions when they're burning diesel. However, you really don't need any water injection at all. There's no system for it, and because it's not necessary. The emission control is down low enough that it can run completely dry. So places nearby, talking about California and places that don't really have this water supply for some of these plants, it's a perfect solution to really help maintain emissions. Well, if you just have liquid diesel fuel available, or even just for emergency situations. I know like places in Florida where it's pretty much a requirement because of our hurricanes and things that we have. You have to have at least the ability to run backup fuel on diesel no matter what the plan is. So for that situation, then you at least wouldn't need the water supply as well.
Is there anything else that you can think of? Or?
I wish I remembered better detail. There was an interesting story I heard. We have a 800 plant in Africa that actually there was a large blackout that happened in this particular region, and the 800 plant was literally the only thing that stayed running.
Really?
And it brought back the entire grid for this region just because of the stability it had. It was able to maintain the load, and has very strong. A lot of it's the combustion system. Having that annular system is actually very robust, and so being able to control really the entire grid helped bring back the entire system. Customers I've talked to who have had 800s, I mean, I've yet to hear of any complaints, really. The real big ones get a lot of publicity, and even air derivatives, I feel like, the slick technology and, aero technology for industrial or the peakers and things like that. So they have the quick starts, but, I mean, you talk about aero derivative starts versus, even an 800 start. If you don't care if it's 5 minutes to 10 minutes, I mean, it's still a very fast startup.
Right, absolutely.
So it depends. You need a very specific need, I feel like, a very specific peaker need, or to need a 5-minute start. And okay, if you need that, they have their air derivative solutions and things like that that can help out. But
well, at this point, you could put in a battery to cover you for 5 minutes.
That's true. Honestly, yeah.
It would probably be well worth it to improve the performance that you have that extra time if you need it.
Exactly. We actually just sold, so we'll be building soon, but a barge project that incorporates 800 with batteries as well. So it's Dominican Republic, and actually the project itself will be on a barge. combined cycle 800 plant, and that also utilizes battery storage. I mean, we hear more and more about it, even talking with customers and what they're interested in, and with the Caribbean and Latin America in particular, they can't handle large gas turbine plants. They can't have that much, that many megawatts really on one prime mover. And so having that is really necessary for a lot of these islands. And for Panama too, and like the Malta plant I mentioned, half of their power is from this 3-on-1 SGT 800 plant.
Wow.
For the whole island. And so that's, you look at other islands in the Caribbean, really they're almost mirroring or at least very similar projects to what the Malta project was, because LNG is growing more and more now in the Caribbean and Latin America as well. They're looking for greener solutions, and LNG is actually becoming, financially feasible in a lot of these areas and these islands. And so this is, you're seeing that pop up more and more on these possibilities of, integrating these LNG regasification facilities with, these 800 combined cycle plants. I mean, it's a perfect size for these type of grids.
And do they also tie in CHP then, or is it just more specific to the LNG?
Either or.
Yeah.
I mean, I've seen both. I mean, there's talks, you have the potential of, they have such a high exhaust energy on the 800s. When you look at the turbine exhaust energy that they can take advantage of. And, I've heard of it with steel refineries and, places that need steady steam, and it's a perfect fit for that type of application too. So either one, it really can adjust to whatever the real main needs are for the site and the customer.
All right. Well, thanks for your time. I mean, I think you shared a lot of really great information.
No, absolutely. Thanks for having me. Yeah, and enjoyed the conversation.